Okay. So we have notes 3.5. Again, still using exponential and logarithmic models, but we're today going to look at the growth model and the decay model. Okay. Am I sharing this one with the, I don't think I am yet. So let me share it. Nope, wrong thing. Gosh, I'm clicking all the wrong buttons right now. Okay. There we go. I think now I'm sharing the right thing and it's recording. Wow, everything is going all right. So again, we're going to talk more about, and this whole chapter 3 has been logarithmic models and exponential models. And then today we are just getting into the exponential growth model and the exponential decay model, which if you have completed advanced algebra, these are two things that you probably have seen before. Okay. Now, the one thing that I like to compare it to is because earlier in chapter 3, we saw PERT, the continuous interest kind of problems. And that's exactly what exponential growth model is. We have our initial condition A, we have our E, our natural E, we have B, our growth rate, that would be like your interest rate, and then you have X, your time. And so we're going to use the same kind of thing, but we like to use more generic letters because with P, we're talking principal investment, R, we're talking interest rate, T, we're talking time. And so we like to use A, B, and X just more generic. The decay model is very similar. We just have this negative b, which flips it over the y-axis. And so instead of being growth like we see here, it flips over the y-axis and becomes decay over here. First problem here, we are going to use our exponential growth model to estimate profits. So we're going to estimate amounts of, in billions of dollars, U.S. online advertising spending from 2007 to 2011. Wow, super interesting. Okay, an exponential growth model that states an exponential growth model that approximates these data is given by S equals, and we can see the growth model here, 10.33 e raised to this thing 0.1022 t 7, and then it's between these years 7 t and 11. S is going to be the amount of spending in billions. T equals 7 is going to represent 2007. And then when the amount, what we're really looking for here is when will the amount of U.S. online advertising spending reach $40 billion? Okay. And so again, we're going to start with the equation that they're going to give us here because that's the exponential model that represents this situation. And so we have S equals, you got this thing, S equals 10.33 E raised to the 0.1022 T. And we're really going to try to look for what that T value is. But we first need to fill in what S is because we can't do two variable equations. I'm just going to make sure everything. I think I have, so to answer one question, I think I've already posted the slides, so they should be up there. And then I can go back to the decay formula, absolutely. Sorry, I forgot that I'm kind of like doing notes here, and I forgot I am not doing like video notes. And so, yes, I can go back. Oops, clicking on wrong things again. Do I need to go back to the, do we want to see the growth model as well, or just decay? All right, I'm going to go to the next slide. If you want me to hop back again, just let me know. So I'm going to start here again, and I'm going to use their equation. I'm looking for time and T, and I'm going to look for when the spending reaches $40 billion. okay? Well, my spending is represented by this S, all right? And so in 2007, my S was 2.1. In 2008, my S was 23.6. In 2009, my S was 25.7. And so in this case, we don't know T, but we know we want S to be $40 billion. And so we're going to rewrite our equation as 40 equals 10.33e raised to the 0.1022 times T. Okay. Now, from here we can solve this because we know how to from the last lesson 3.4. We know how we can solve these when we have variables in the exponent. Just going to check one more time for questions. Okay. And then I'm going to keep going from here and solve the rest of this. So the first thing I'm going to do is I'm going to divide both sides by 10.33. So I'm just left with E on that one side. So dividing here by 10.33, dividing here by 10.33, and I got to grab my calculator because I know I'm going to need to use it throughout this lesson. So I have 40 divided by 10.33, and that's going to give me 3.87. So now I have 3.87 equals E to the 0.1022 times T. Well, to get rid of E and to bring down the stuff in the exponent, I need to take the natural log of both sides. And so this becomes then the natural log of 3.87 equals the natural log of E to the 0.1022 times T. The power rule is going to bring the exponent down, and the ln of E equals 1. And so what I'm going to be left with here is going to be the ln of 3.87 equals 0.1022 times T. Last thing I need to do is divide by this decimal over here. So I'm going to divide and divide. And what I'm going to end up having is T equaling whatever this division is going to give me. Again, I'm using my calculator here. And that gives me 13.24. So 13.24. And because my T is really in years, you can see, where does it say that? T equaling 7 represents 2007. So T equaling 13, a little over 13, is going to represent that in the year 2013, we're going to hit that $40 billion. So I always like these problems because even though this seems a little outdated, it is a little bit applicable, and I'm guaranteeing that somebody is using these exponential growth models somewhere to represent, hey, where are we going to be in a few years? Any questions on that first problem? Not too bad. It's all about, again, just reading the problem closely and setting it up correctly so that we can get our correct answer. Once we have it set up, it becomes a problem like we saw in 3.4. So I'm going to wait a minute to see if questions come in through the chat. Otherwise, I'm going to move to the next one. The next one is longer. There's a lot of steps that go with it. And I think there is a question that's similar to it on the test. So I want to make sure that I go over it thoroughly and that I can answer any questions you're going to have on it. I feel weird, like I'm not in the camera. Maybe if I back up. Again, I'm going to just wait a minute and then we'll do the next one. All right, I'm going to keep going for the sake of time. Maybe get you off the chat sooner. And if you have a question, I can always go back and answer it. I'll keep checking after every problem. All right, so the next one. In a research experiment, a population of fruit flies is increasing according to the law of exponential growth. So that is y equals a times e raised to the bx. After 2 days, there is 100 flies. After 4 days, there is 300 flies. How many flies will there be after 5 days? Okay. And so this is growing exponentially. So you'll see the way that we're going to set it up. We're going to take it one part at a time. We're going to start with 2 days and 100 flies, and we're going to collect some kind of data from that. We're going to then do 4 days with 300 flies, collect a little bit more, and then we're going to finally be able to have enough information to plug in for 5 days. And so we're going to start with 2 days and 100 flies, and we're going to use the equation y equals ae to the bx. Okay? Well, we know why, because after this certain amount of time, I have 100 fruit flies, or 100 flies. And so y is going to be my 100. A, I don't know, because I don't know my initial amount. I don't know where I started with these number of fruit flies. I know that I just have A. And then E, B to the X. I don't know the rate that they're increasing, so I don't know my B value. I don't know my rate that they're increasing, but I do know that I have 2 days have gone by. So again, just picking out the right information here. After the growth has been happening, we have 100 flies, and we know the time is 2 days. Everything else at this point, we do not know. Okay. Now from here, what we need to do is we are going to divide both sides by e raised to the 2b. Okay. We're going to divide both sides by e raised to the 2b so that I can have at least something set equal to a. So I can have a set equal to something. All right. And so that's what I'm going to do here. I'm going to divide both sides by e to the 2b, which is the same thing if I rewrote it up top, and divide this side by e to the 2b so that these cancel here. What I have then is that a equals 100 divided by e to the 2b. That's nice because now I have at least an a value to work with. And that's really where the problem has to end right now for the 2 days and 100 flies. And so now I'm going to start setting up one for the 4 days and 300 flies. Okay, and I'm going to change colors so we know that I'm working with that. 4 days, 4 days, 300 flies. Okay, we then have, again, we start with y equals a to the e to the bx. This time my y is going to be 300. My a, I can replace my a with this here because I found out what that was in the first part. And so this is then 100 over e to the 2b times, because I just replaced my a, e raised to the 4b. Any questions there? That's where things are getting a little trickier. Any questions there so far? What I did is I just replaced my a with what I found before in the first part. And then I have e to the 4b because this is representing 4 days. Still do not know my growth rate of b yet. All right, I'm going to keep moving. If you have a question, throw it in the chat. Okay, so I can then, because of what I'm seeing here on the left, or sorry, on the right in red, I can rewrite this equation because this is multiplication here. This is multiplication, so I can rewrite it as 300 equals 100 times e to the 4b divided by e to the 2b. All right, when we divide exponents, it's like subtracting. So what we end up having here is 300 equals 100 times e to the 2b, because again, like subtraction says 4b minus 2b would give me 2b, and that's what we really do when we're dividing with exponents. All right, from here we can keep going now, and we can actually solve this for b. And so I am going to just keep moving down this line. I'm going to divide both sides by 100 here. I end up having 3 equals e to the 2b to bring down the 2b and to get rid of the e, I got to take the ln of both sides, the natural log of both sides. This is going to cancel here. I'm going to be left with the ln of 3 equals 2b. Dividing by 2, I have my answer for b. ln of 3 divided by 2 equals b. All right, this is great so far. I'm almost done. I got so many pieces now. And what I'm going to do quick, I'll check for questions quick, but then what I'm going to do is I'm going to plug my b value in to my equation here, because if I plug b in, I can actually get an answer for a. So I'm going to work in a circle here. I brought this up to here. Now I'm going to bring what I found back up to here. Okay, so plugging this into up here, I end up having, let's put it in a different color. Now let's stick with red. I have a equals 100 over e to the 2, and then this is now raised to the ln of 3 over 2, like that. Okay, again, this is calculator work for me, and so I'm going to do this on my calculator here. So I got to do the 100 divided by e raised to the 2 ln of, and I'm going to start by doing e raised to that thing, that mess. E raised to, well, what I can see here quickly is this is multiplication here, so my 2's are going to cancel. So this is really e raised to the ln of 3, which is actually makes this much easier for me on the calculator even. And e raised to the ln of 3 is just 3. And so what this really is, not too bad. It says a equals 100 divided by 3, which tells me a equals 33.33. That's really nice for us, actually. Because now we have an a and we have a b. And we should have enough information now to actually plug in and figure out how much or how many fruit flies there's going to be after 5 days. How did you just divide off the 100 and then put the e's over each other? I'm guessing this question is talking about this part right here, or maybe even the step before it here. So what I did here on this step was, because this is multiplication, this is 100 over e raised to the 2b times e to the 4b, I rewrote it. So I rewrote it here, and I got 300 equals 100 times e to the 4b over e to the 2b. I'm allowed to do that again because it's multiplication. You know, addition, subtraction, we need a common denominator. With multiplication, I can move this, instead of being 100 over e to the 2b, I can make it e over 4b. Because another way we can see this is, I don't know if I have room to write it on here. Let's open it up. Different ways you could write it. You could have 100 over e to the 2b times e to the 4b. You could rewrite that as 100 times e to the 4b over e to the 2b. You could even rewrite that again as the way I wrote it, as 100 times e to the 4b over e to the 2b. There's different ways you can write that because it's multiplication. I actually don't mind seeing it as this way right here, because then I can do the same thing where I divided here. I divided there, and I ended up just with 100 times e to the 2b. I think that's what that question was talking about, because that's the part where things got more confusing. Otherwise, I'm trying to see if there is another area where that could have happened. We had e here. That went away. So let's just, again, I'll end the problem here. I got a little bit left to go, and then I'll wait and answer more questions about specific parts if we have them. So underlined in blue, I have my A and my B. I need to set up one final exponential function and solve for how many flies there's going to be after 5 days. And so I'm going to do this in blue. We have y equals a to the e to the bx. I now know a lot of these values. I don't know why, because that's going to be the number of flies. I don't know why, but I do know a is 33.33. I know e is e. I know b is the ln of 3 over 2. And I know x is going to be 5 days. And again, this is calculator work and solving from here. So the first thing I'm going to do is the ln of 3 divided by 2. Take a step back here. The ln of 3 divided by 2 times 5. And that gave me 2.74653, some long decimal. And I'm going to do e raised to that. May be dismissed, and Sophia Campbell, please come to the office when you have a moment. And what I get when I do e raised to these two things, e raised to the ln of 3 divided by 2 times 5, I end up having y equals 33.33 being multiplied by 15.59. Multiplying this out, 33.33 times 15.59. I get that there is going to be 519.61 flies. Spell flies right? I did. 519.61 flies. I should really round it up to 520 flies because you can't have 0.61 flies. So we'll round it up to 520. 520 flies after 5 days. And I'm going to sit back down and I'm going to try to answer any questions about this problem because, again, this is a problem that is, I believe, on the test, or a problem similar to this is on the test. And I want to make sure that we understand what happened here. And so we're going to kind of start from the beginning and recap it. So again, I started here with y equals a e bx the first time in black. And I took the very little information they gave me and I started working with it. So I put in the 100 for 100 flies. A I didn't know, E is E, B I didn't know, but I did know X because we had 2 days. I then just decided to, and this is a step that you need to do in this problem, divide both sides by E to the 2B and E to the 2B, or, whatever, we had up here, E to the power. All right, so then I got some rough value of A, where I still had a variable in it, but a rough value for A that I could use in my second equation. And that's what I did. I had a second time using the exponential growth model, this time 300 flies. And I plugged in A as the A value I had, which was 100 over E to the 2B, times E to the 4B. And that 4 is coming from, again, that was 4 days that time. This is where the question came in about what I was doing. And what I did again was that I rewrote that multiplication. I rewrote this multiplication as 100 times E to the 4B over E to the 2B. So just moving it, instead of being under the 100, moving it to be under E to the 4B, which I'm allowed to do because it's multiplication. And there's these different ways that we can write multiplication, like we saw here on this extra slide. Okay, then from here, I start solving it for B. So I divided both sides by 100. Well, I should really talk about this step one time. Again, quick, E to the 4B divided by E to the 2B. That's division. And so like the exponents are subtracting there. So we can see it as 4B minus 2B. And that's where we get E to the 2B here because of the 4B divided by 2B. They're subtracted really. And then I divide both sides by 100. I'm left with 3 equals E to the 2B, ln of both sides to get rid of the E and bring down the exponent. Divide both sides by 2, and I come up with this B value. I then take the B value and plug it back in so I can find an actual number for my A. That's what I did here. I plugged my B value in and solved for A. And again, this is a lot of calculator work there. And then once I had an A and a B, I can then plug into my equation and solve for Y. Because they gave me an X, I had a B, I had an A, I could solve for Y. No questions so far coming in. I don't have many more questions to go. I think I have just one, maybe two. I think maybe two. Let's just, and this one is a little bit longer here, and then the last one's kind of short. So let's get into this one. We have radioactive iodine has a half-life about 60 days. Suppose a nuclear accident occurs and gives off an initial amount of radiation. How long will it take for the radioactive iodine to decay 20% of the original amount? All right, so this word decay here is kind of confusing because it makes you want to use exponential decay here, but we're actually going to be using our growth model. And I'm going to start setting it up because really what's happening is it's growing at some amount and then it starts growing slower, right? It's growing exponentially and then it starts growing slower. So it's really talking about if it's going to decay from its original amount, which is a confusing wording of this problem. And I just want to check my finished notes that I posted to make sure that I am correct in making that statement. And so yes, I'm going to end up using the actual growth model here, interestingly enough. Okay. So I'm going to start with, it's got a half-life of about 60 days. The nuclear accident occurs and gives off an initial amount C of radioactive decay. And how long will it take for the radioactive iodine to decay to 20%? Okay. So the first thing, again, we're going to start with Y equals A to the E bx. Okay. My initial amount A is always my initial amount. I'm going to replace that with C because that's what they were saying in this problem is the initial amount is C. Okay. And so I'm going to say now Y equals C, that's the initial amount, E, and what else do I have? I have 60 days, so a half-life of 60 days. Okay, well that means, this is kind of confusing, all right, so I want to say it, maybe I'll get closer to the computer so you can hear me a little bit better. So what this means is after 60 days, your initial amount is cut in half. So we actually are going to have a Y value here, or a value we can replace Y with, and that's going to look like this. Okay, 1/2 times C, so half the initial amount of C is going to be my Y, that it's going to happen. If CE raised to the B, and then X is going to be 60. Okay, see, X is my time, so I put in 60 for 60 days. C is my initial amount, and what we get out of that after some rate of decay that we'll figure out is going to be half the amount of C. Okay, and we don't really know C yet. But from here, we can start solving. Here we can start solving and trying to figure out where it's going to be at that 20% mark. So I'm going to divide both sides by C. Divide both sides by C. They cancel out. So I'm left with 1/2 E to the B. Sorry, 1/2 equals E to the B 60. Natural log of both sides, so natural log of 1/2 equals the natural log of B to the 60. This becomes then ln of 1/2 equals B times 60. Dividing both sides by 60, I get ln of 1/2 divided by 60 equals B. So pretty good, not bad. So now I have a B value, and I'm going to check quick for Sorry, not the right thing. Where am I at? There we go. No questions yet on this one.
Okay.
Yeah.
What is y supposed to equal for the equations? Because like I just see you put it on there and then we just put something in for it. So I'm confused about like what it means.
So it's like our output. Like in the first problem, it represented the amount of flies after the certain amount of days. So it's our output of like A is would be our initial amount, and then E is our just constant, natural constant, B is the growth rate, X is time. And so once you input everything, you get this output. In this case, it was flies. In this case, it would be amount of radiation after a certain amount of time. It's our output.
Okay, thank you.
Yeah. And so that is why it's changing every problem, because in this problem, we're talking about the amount of radiation that's going to be left. That's going to be our Y. In this problem, it was the amount of flies that are going to exist after a certain amount of time. It's just going to be like, yeah, I said the output there. Right now, I got a B value. That's where I'm going to pick back up. And we're going to start with kind of a new one. And we're actually going to use, we're going to plug in a B value that we figured out. We are going to use the same initial amount C. The only thing that we're going to change is our, instead of 1/2, we want to find out about 20% of decay. So we're going to go from here. Again, we're going to start, I'll change colors here. We have Y equals A E to the B X. This time, my initial amount is still C because I'm kind of restarting from the beginning again. I haven't really found anything. So my initial amount is C. E. B is what I have here, the ln of 1/2 divided by 60. And my X, I don't know. And what I'm looking for this time, because really what I'm going to try to solve for is my X value, the amount of time it's going to take for us to reach 20% of the original amount of radiation. And remember, C represents my initial amount of radiation. So my output, what I want to see is my output is 20% of C. And a way to write that would be 1/5 times C. So again, I'm setting up a very similar equation here. My output I want to be 1/5 of my original amount. My C is my original amount. E is the E. We have this function here, this value for B, and we're looking for X. Okay, so the first thing I'm going to do is I'm going to again divide both sides by C because I can. Which leaves me with 1/5 equals E to the ln of 1/2 over 60 times X. I'm going to take the natural log of both sides so I can bring down that exponent. The natural log of 1/5 equals the natural log of E ln of 1/2 over 60. The 6 looks like a 20. I don't want that. 60 times X, which reduces to ln of 1/5 equals ln of 1/2 over 60 times X. I'm going to do the ln of 1/2 over 60 on my calculator so I can divide it over. So the ln of 1 divided by 2 divided by 60 gives me a actual negative. It gives me a negative 0.0112, which is good. By then ln of 1/5 equals negative 0.1. Oops, sorry. Looking at my calculator wrong. 0, 1, 2 times x. I can then divide by both sides here by negative 0.012, negative 0.012. And I have the ln of 1 divided by 5 divided by 0.012, negative, sorry, 0.012. And that gives me 134.12 equals x, which I believe that's going to tell me the days. I believe that is days. So 134 days, a little over 134 days. It's going to take for the radiation to go down 20%. I can feel myself as I teach this that these topics are hard. The good news is on the test, there's a couple good news here. On the test, there's only going to be one problem like this, okay? And the other good news is that we have now seen these and we can work more with them. And so there's going to be some problems on the homework that we get to practice it with and ask more questions with, okay? And it's a lot of just trying to get what we want and just trying to put in the correct numbers and seeing if we're getting the right values here. And so we can see, again, I'm going to kind of recap this problem and what I was doing. We had my original my original equation here. We can kind of skip the second step because I was talking about how I was going to set it up. And what I ended up doing here was I said, okay, I needed to figure out 1/2 of my C was going to happen after 60 days. So 1/2 of my initial amount was going to happen after 60 days. It seems weird now that I think about it, though, that it would be 134 days for only 20% of it to go away. Let's check my answer. $134.342, that's right. Oh, it's because it goes down to 20%. Okay, I got it. Because it's talking about that would be at 50%. It's gone down even more. It's gone down to 20%, so it takes longer. Okay, anyway, back to the recap here. We wanted to say, okay, our output needs to be half of the initial amount at 60 days. So we plugged in everything we could, divided by C's, ended up with 1/2 equals this, used our ln function to bring things down, to get rid of the e and bring down the exponent, and then ended up with what we have here, which ended up being our b value. So again, an ugly looking b value, but at least we have a number that represents b, our rate of change. Well, we can then start again by plugging in, okay, C is our initial amount. We're looking for 20% of C or 1/5 of C. That's what we want as our output. And then we have E, we have a B value that we plug in, and this time we're looking for time. So just make sure when we're reading these problems that we are trying our best to choose the correct information. And so we'll finish the problem, then I'll come back to picking the information out. As I kept working it, I divided again both sides by C because I could. There's a C here and a C here attached by multiplication. I can divide them both. I ended up with this here. Then I was able to take the natural log of both sides. The natural log got rid of the E and brought down the exponent. And I continued to solve until I got to a value for X, which was 134 days. Now, when you read a problem like this, just make sure you try your best to take out the information that's available. So radioactive iodine has a half-life, which means that the initial amount gets cut in half at about 60 days. So suppose a nuclear accident occurs and gives off an initial amount of C of radioactive decay. So a couple big things. Initial amount of C. So we do know we know our A value is really represented by C. We have a time of 60 days, so our x can be 60. And we know a half-life means that after 60 days, your C value is cut in half. And so you can start plugging in like I did in solving. Once you come up with a B value, a rate of change, then you go back to the top and you say, okay, what else are they going to give me here? And it says, how much will it take for that radioactive iodine to decay 20%? So our initial amount is still C. They didn't change that. We're talking now we want our output to be 20% of the initial amount, and that's where the 1/5 over times C came from. And then we know we have our B value we saw from the beginning. And since it's asking how long will it take, I know I'm looking for X, I'm looking for time. There is just one last problem I want to talk about. There is these notes here about the Gaussian model. And I believe it's just representing your curve, your bell curve. And it's a way that we use it in statistics. It's not used in pre-calculus. So if you plan to take statistics, you can take notes on this Gaussian model. Otherwise, I am going to kind of skip over it because we don't need it for this last problem. So the last problem here is a little bit quicker. And I'm just going to set it up. I'm not going to solve it. The notes are going to be in the Google Classroom. And I know I said 9:30 and I want to stick to that. So I don't want to go over the time. I'm going to take one quick look for questions and then we'll get right into it. Okay. So how many students are going to be infected after 1 day? So we got to read the problem quick. On a college campus, 5,000 students. One student returns from vacation with a contagious and long-lasting flu virus. How funny. The spread of the virus is modeled by this function here, where y is the total number of students infected after t days. The college will cancel classes when 40% or more of students are infected. And so we want to see how many students are infected after 5 days. Well, we have our model. Y is going to be the number of students infected. T is time, so we would plug 5 in for t and solve the equation. And I think for the sake of time, I'm not going to do that because I think we couldn't plug in 5 and solve that. What I want to do, though, is how many days until the college classes are going to be canceled. Okay? And so I know that when 40% of the student population is infected, they're going to cancel college classes. So I need 40% of 5,000. That's going to be my Y value. Okay, so if I can do that on my calculator, 40% I believe is 2/5. So 2 divided by 5 times 5,000. That's going to give me 2,000 kids. So we can set up the equation as such. 2,000 is going to be my Y. That's going to be the number I want to see like when we reach it. We have 5,000 divided by 1 plus 49999 e raised to the negative 0.8 times t. Okay, now that I have it set up from here, we can solve it. The first thing that I would do to solve this is I would, let's see, what do I want to do? I can multiply both sides by that. That's kind of ugly. There's different ways to go about this. Let's do, I'm just trying to think of the best way. Sorry, I'm wasting time, I know. I can multiply both sides by that ugly mess, but I don't want to do that. What I'm going to do, and this is going to be kind of weird, I'm going to flip both sides here. So this is going to be 1 over 2,000 equals 1 plus 499 e to the negative 0.8 t over 5,000. I'm just flipping both sides here. I'm flipping both sides because I just didn't want to multiply by that mess on the bottom. It's kind of a little cheap move that I'm doing here. All right, so it's definitely legal to do, but it's not maybe the best, but it's legal, and I want to do it this way. So I'm going to multiply both sides by 5,000 now. I got 5,000 over 2,000 equals 1 plus 49999 e to the negative 0.8. All right, I can do the division here. 5,000 divided by 2,000. That gives me 2.5 equals 1 this thing here. minus 1 on both sides. This is 1.5 equals divide by 4,000. And then I have, I'm getting closer, 1.5 divided by 499. Ooh, that's so small that my calculator doesn't want to do it. So let's leave it as that, 1.5 over 499 equals e to the negative 4.8t. Take the natural log of both sides. Sorry for rushing here at the end. Let's see if we can do the natural log of this mess now. Again, this is negative 8.112. Canceling. Oh, oops, sorry. Let's cancel here. This is negative 8t. Sorry, divided by. Sorry for rushing there at the end. I just wanted us to see it. It probably wasn't even worth it with how fast I went. That's all I'm going to do. It's 9:30 and I don't want to hold us any longer. I'm going to upload these notes to the Google Classroom so you can rewatch them if you want to. The homework I am going to post. I'm not going to show it here now because I'm going to cut a couple problems out, and then I'm going to post it in the Google Classroom when I post the notes too. All right. I thank everybody for joining. I know this lesson is tough. I will set up a Google meeting tomorrow at our regular time so we can talk about some of the homework problems. And then we can go over another one of these, or like I said, we'll go over some homework problems and we'll try to keep figuring these out. These are challenging. This is the last part of chapter 3, so it gets challenging. But we'll keep working on them. We'll keep trying to understand it. And so if you want, you can leave the meeting. And again, I'm going to be posting that stuff in Google Classroom, so just keep an eye on it. And the numbers for homework will be posted shortly.